Okay, so we're going to talk about the final stages of aerobic respiration, which is the electron transport chain, which happens in the inner mitochondrial membrane. And oxidative phosphorylation is going to happen later on as well when the energy used to synthesize our ATP, which is 32 to 34, is going to be derived from the oxygen that our hydrogen is carrying. So for step one, the hydrogen carriers NADH and FADH are going to be oxidized. So their hydrogens and electrons are going to come off, and they're going to release energy. The hydrogens are going to come up through this gradient and come up to the top and the upper part of the membrane, but the electrons are going to stay right here. So the electrons are going to be transferred through the chain, through the inner membranes, proteins, and they're going to lose energy in the chain to pump H plus ions from the matrix, so they're just going to keep going along. And as that goes, H plus ions are going to go up through these proteins. And then that's going to create a gradient up here where the accumulation of H plus ions within the space. So it's going to make an electrochemical gradient, and this gradient is going to force the H plus ions to diffuse back into the matrix. So they're going to come down. And this is chemiosmosis, and it's facilitated by ATP synthase. And as the H plus ions move through ATP synthase, they trigger the rotation of the enzyme over here, making our ATP that we get as heat. And in order to continue functioning, the de-energized electron that's still in here is going to need to be removed so that it doesn't block the chain reactions. So oxygen is going to act as a final acceptor of this electron, and the ions that come off of it, like the hydrogens, are going to attach as well. So we get water from that reaction, and the oxygen is just going to bind with those free proteins in the matrix to make water and maintain our hydrogen gradient. And then at the end you should have 32 to 34 ATPs, 6 waters, and a lot of energy.